I'm your friend Shadab Imam, and first of all, Merry Christmas to all the viewers. And so we are continuing our lecture series on operations research, and today I have came up with a very beautiful question which shows degeneracy. So we are going to learn degeneracy in transportation problem today, and let us start the problem. So the problem says that there are 4 factories 1, 2, 3, 4 with a availability 40, 30, 20 and 10 respectively, and there are 5 warehouses W1, W2, W3, W4 and W5 with the demand as 30, 30, 15, 20 and 5 respectively. So our objective is to minimize the total cost, and here the unit transportation cost in rupees is given from factory I to warehouse J. So our objective is to minimize the total transportation cost, and we know that our transportation problem is solved in 2 parts. First is to obtain the basic feasible solution and then to check for optimality. So we are going to use the Vogel's approximation method to calculate the basic feasible solution. So we will use Vogel's approximation method for calculating the basic feasible solution. So this is our given matrix where factory 1, 2, 3 and 4, and there are number of warehouses 1, 2, 3, 4, 5, and these are unit transportation cost in rupees. So let us start. So in Vogel's approximation method, what we will do is we will calculate the penalty that is in each column, and in each row we will calculate the difference of minimum value and the next minimum value, and this is what we call penalty. So let us first calculate penalties for all the rows and columns. So minimum here is 5 and next minimum is 6. 6 minus 5 is 1. So penalty here is 1. Similarly for this, 5 is the minimum, 6 is the next minimum, penalty here is 1. In this row, minimum is 4, next minimum is 6, so the difference is 2, hence the penalty is 2. Here the minimum is 5, next minimum is 6, so penalty is 1. In this column, minimum is 5, next minimum is 6, so penalty is 1. Now moving on to row, we have minimum as 4, next minimum is 5, so the penalty is 1. Similarly, in the next row, minimum is 5, next minimum is 6, so the penalty is 1 here. And in the third row, minimum is 5, next minimum is 6, and penalty here is also 1. And in the last row, minimum is 5, next minimum is 6, and the penalty is 1. So among these, we need to select the maximum penalty here. So we can see that the maximum penalty is 2. So what we'll do is we will select this and we will try to allocate in this column where we have minimum transportation cost. So in this column here we have minimum transportation cost. So let us see the supply and demand. Supply is 40 and the demand is 15. So out of 40, 15 can be allocated. So I will allocate 15 here. So after allocating 15, I can see that there is no allocation can be done in these 3 cells, and this will become 0. And out of 40, the remaining is 25. Okay. So now again we need to calculate the penalty for the remaining matrix. So I'll just erase this and again calculate the penalty. Here the column does not change, so the penalty will be same for these 4 columns. Only row penalty will change. So here the minimum value is 5, next minimum is 6, so the penalty is 1. Here minimum is 5, next minimum is 7, because 6 is now not eligible, or I can say not active. So the minimum is 5 and the next minimum is 7, so the penalty is here 2. Similarly we have 5, next minimum is 6, so penalty is 1. Here we have minimum 5, next minimum 6, and the penalty is 1. Now among these we can see that 2 is having the maximum penalty. That means we will select this, and in this particular row we will select the minimum transportation cost. So this cell is having minimum transportation cost, and we will try to allocate maximum value here. So we can see that this has the supply of 30 and demand is also 30. That means 30 can be allocated here, so that this will become 0 and this will also become 0. And we can see that no more allocation can be done here and here. Similarly, no more allocation can be done here and here, because both demand and supply are fulfilled. Now again we need to calculate the penalty. So I am again erasing this, and again we will be calculating the penalties. So let us now calculate the penalties. Here minimum is 5, next minimum is 6, so penalty is again 1. Here it has been fulfilled, this is fulfilled. Here we have minimum is 5, next minimum is 6, so penalty is 1. Here minimum is 5, next minimum is 6, so penalty is 1. Now in this row minimum is 5, next minimum is 7, because these two cells are not eligible now. That means minimum is 5, next minimum is 7, so the penalty is 2, and this has been fulfilled. So we'll move ahead. Minimum is 5, next minimum is 6, so this will be 1. Minimum is 5, next minimum is 6, so penalty is 1. Now among these we have maximum penalty here. That means we will select this row, and among this row we will find the minimum transportation cost is occurring at this particular cell. So we will try to allocate maximum at this cell. So we can see that now the supply is 25 here and the demand is 20. That means out of 25, 20 can be allocated here. So 20 has been allocated here, and this will become 0. After allocating 20, we cannot allocate any more in this column, and this will become 5. So now again we will calculate the penalty. So because row 1 and row 4 does not change, the penalty will remain same, and this will be gone because the demand has been fulfilled here. Now we need to calculate the penalties for row. So now again we are calculating the penalty. So the minimum cost here is 7 and the next minimum is 9, so the penalty is 2. Similarly, this has been fulfilled, and here minimum is 5, next minimum is 6, so penalty is 1. Here also minimum is 5, next minimum is 6, so penalty is 1 here. So we will select the maximum penalty. This will be the maximum penalty, and in this row we will select the minimum transportation cost. So here is the minimum transportation cost, and this is having the supply of 5 now, and the demand is 30. So out of 30, 5 can be fulfilled. So this is 5, and now this cannot be fulfilled. Okay, and here we have 25 as the remaining. So again we need to calculate the penalties. Again we will be calculating the penalties. Okay, so let us calculate. This is 5 and 6, so penalty is 1. Fulfilled, fulfilled, fulfilled. Here we have penalty is 1, and this has been fulfilled, this has been fulfilled. Here the penalty is 1, minimum is 5, next minimum is 6. Here also we have penalty as 1. So sorry, so we can see that all the values of penalty are same, so we can select any one of them and move ahead. So I will select this one, first one, and in this particular column I can see that 5 is the minimum transportation cost. So I will try to allocate maximum here, and for this cell the supply is 10 and the demand is 25. That means out of 25, 10 can be allocated here. So I will allocate 10. So this will become 15 and this will become 0. So after this will become 0, that means no allocation can be done here. And now we can see that only one row is remaining. That means we are now forced to allocate the remaining values in these particular cells. So let us see, here we have to allocate the remaining 15 quantity, here we have to allocate 5 quantity, because after allocating 15 there we have 5 remaining, and after allocating 5 we have 0. Similarly here will be 0, here it will be 0. So now we have a basic feasible solution here, and I am going to write that basic feasible solution in this particular matrix to test for optimality. So let us write the basic feasible solution. This will be 5, 15, 20 and 30. This will be 15, this will be 10 and this will be 5. Okay, so now we have, I am just erasing this for the purpose of calculation only. Okay, so I am writing here 0 directly. And now before moving on to the optimality test, we need to see whether the solution we have got is basic feasible solution or not. So let us see, it must have m plus n minus 1 number of allocation. Therefore for 4 rows and 5 columns, m plus n minus 1 will be 4 plus 5 minus 1, that is 8. And the number of allocation we are getting is 1, 2, 3, 4, 5, 6 and 7. So we know that number of allocation is less than 8, where 8 is m plus n minus 1 number of allocation. So in this particular case we have studied that this is the case of degeneracy. So we are having degeneracy here, and what degeneracy means that degeneracy does not affect our solution whenever we are obtaining a basic feasible solution. But in order to find out the optimality, whether or to check for optimality by either stepping stone method or by modified distribution method, we need to have all the m plus n minus 1 number of independent allocations. That means total number of 8 allocations has to be there so that we can proceed. At the moment we have 7 independent allocations here because they are not forming loop with each other. So what I will do is I will select one cell which is not having loop and allocate the value epsilon there. So epsilon is the value I am going to allot here on that particular cell. And what epsilon suggests, that epsilon suggests that it has null allocation. That means there is no allocation in that particular cell. So let us see what and how can we select that cell to be an independent allocation. So we will generally select the minimum cost cell having the minimum transportation cost. As we can see that in these empty cells, 6 is the minimum value of transportation cost. That means there are 4 cells having the value 6, so I can allocate at any one of them. But you can see that if I allocate in this particular cell, if I allocate epsilon here, you can see that this will clearly forming a loop. So this will form a loop. That means if I allocate here, then our solution will not be a basic feasible solution because this is forming a loop. Similarly, if I allocate epsilon here, we can see that this is also forming a loop, this is also forming a loop. So by allocating here also, our solution will not be a basic feasible solution. But if I allocate here, I can see that on moving upward, here it cannot move downward, and here it can move downward, but it is not coming back to the same point. That means it is not forming a loop. That means I can allocate epsilon in this particular cell. So now I have allocated the value epsilon, which suggests that it has null allocation. That means zero allocation it suggests. So let us move ahead. Now we have total 8 number of independent allocation, 1 2 3 4 5 6 7 8, and now this can be our basic feasible solution. So how do we check the optimality? We will check the optimality by using modified distribution method, and we know that in modified distribution method we will have certain variables. So let us quickly see u1, u2, u3, u4. Similarly, v1, v2, v3, v4, v5. Now we need to calculate the values of u's and v's. So we'll do it with the help of these 2 points. First is that for the allocated cells, or which we call as basic cells, Cij is equals to ui plus vj. So here for all the allocated cells, these are allocated cells, for all the allocated cells the value of Cij, that means unit transportation cost, is equals to ui plus vj. So what we'll do is we will select any of the variable as 0 and calculate the values of the corresponding variables. So I am selecting this value u1 as 0, and now I'll be calculating the remaining values. So we can see that for allocated cell 7 is equals to 0 plus v1, or I can say that 0 plus what equal to 7. So we can easily say that 0 plus 7 is 7. Similarly, for this allocated cell, 0 plus what equals to 4. So this is 0 plus 4. Similarly, this is also allocated cell, 0 plus what equal to 5. So this will be 5. And once we have calculated these 3 values, we can calculate further 7 plus what equal to 6. So this will be 1. 7 plus 1, this will be minus 1. 7 plus minus 1 is equals to 6. Similarly, 7 plus what equals to 5. 7 plus what equals to 5, that means 7 plus of minus 2 is equals to 5. And from u3 we can say that minus 1 plus what is equals to 5. So we can write here 6, that means 6 plus minus 1 will be equal to 5. And so okay, one value is remaining. So 4 plus what equals to 6. So we can say that this will be 2, that means 4 plus 2 is equals to 6. Similarly, 2 plus what equals to 5. So 2 plus 3 equals to 5. So now we have calculated all the values of u's and v's, and now we need to calculate the values at the empty cells, or what we can say non-basic cell. So for non-basic cell we need to calculate the value of Cij minus of ui plus vj. That means for cell 1 2, Cij is 6 minus of 0 plus 3. That means 6 minus 3 is plus 3. So this will be plus 3. Similarly, here 9 minus 0 plus 6. That means 9 minus 6 is plus 3. So this will be plus 3. This is 8 minus 2 plus 7. So 2 plus 7 is 9. So 8 minus 9 is minus 1. And this is 7 minus 7 plus 2 plus 5. 7 minus 7 is 0. so this will be 0. 8 minus 2 plus 6, 8 minus 8 is 0. Here 8 minus 3 minus 1 plus 3, that means plus 2. 8 minus 2 is plus 6. Here 9 minus 1 plus 4, that means 3. 9 minus 3 is plus 6. Here 6 minus 1 plus 5, that means plus 4. 6 minus 4 is plus 2. Here 7 minus of minus 2 plus 3, that means 1. 7 minus 1 is plus 6. Here 7 minus 2 plus 4, that means 7 minus 2, which is plus 5. Here 8 minus 2 plus 5, that means 8 minus 3 is plus 5. And here 6 minus 2 plus 6, that means 6 minus 4, that means plus 2. So now, as we have calculated the values at all the non-basic cells, we can see that all the values except this cell is either 0 or positive. That means by allocating in these cells, the total transportation cost will increase by plus 3 rupees. Here it is increased by plus 3 rupees. Here it will not increase. Here it will not increase. Here it will increase by plus 2. And there is only one cell 2 1, which shows that by allocating here, the overall transportation cost will decrease by 1. That means there is a chance of improvement. So what we'll do is we will select this cell and we will allocate plus theta here. So what is theta? Theta is the maximum value that we are able to allocate in this particular cell. So once I allocate theta here, this will form a loop, because now there are more than m plus n minus 1 number of allocation. That means more than 8 allocations including this one. So this will form a loop. So it is clearly forming a loop here. So here it is forming a loop, and to maintain the demand and supply, if this is plus theta, this has to be minus theta. This is minus theta, this has to be plus theta. If this is plus theta, this has to be minus theta. Now, as we have discussed in the previous lectures, that the value of theta, where we have plus theta, can be increased indefinitely. So what we have to see here, the value of minus theta, that means 5 minus theta and epsilon minus theta. So we have two options or two limitations. That means either 5 can be theta can be 5, that means 5 minus 5 is 0, or theta can be epsilon. Okay, and we know here that the value epsilon has 0 allocation, but the value of theta cannot be put directly 0. We need to use the value epsilon judiciously. So what we will do is, the maximum value of theta in this particular cell can be of epsilon. That means it can be epsilon minus epsilon. So in this particular cell, what we will do is, we will put theta is equals to epsilon and put in this equation. Now let us find this. So in this particular cell, this is epsilon minus epsilon. Epsilon minus epsilon means 0. So there will not be any allocation here. And this will be 15 plus epsilon. 15 plus epsilon, here epsilon has null value, no allocation. That means 15 will remain here. So this will be 15. And this is 5 minus epsilon. That means 5 minus null value. Null value, that means 0 allocation. So this will remain 5. And here plus theta, that means plus epsilon is here. Epsilon is here. And now the remaining allocations have not changed, so I am writing them. This will be 20, this is 5, this is 15, this is 10, and this is 13. So we have 8 number of allocations here, 1 2 3 4 5 6 7 8. So we have 8 number of allocations here. So this is our new improved basic feasible solution, and to check the optimality, what we will do, we will again use the modified distribution method. But before doing that, we need to understand that from the previous matrix our solution does not change here. The only thing it changes is that the epsilon has been shifted from one place to other. So here we can see that previously epsilon was here, and after doing improvement or iteration, the epsilon has been shifted to this place. This is called shifting of epsilon, and because of degeneracy, our solution here, that means the actual allocation, has remained same in this solution also. So now let us again calculate the values for u's and v's. So we will have u1, u2, u3, u4, v1, v2, v3, v4, v5. So we'll take u1 equals to 0. Now 0 plus what equals to 7, so this will be 7. Similarly for this allocated cell, 0 plus what equals to 4, this is 4. 0 plus what equals to 5, this is 5. Now this is 7. 7 plus what equals to 8, that means 7 plus 1. Here 7 plus what equals to 6, this will be minus 1. Here 7 plus what equal to 5, this will be minus 2. Similarly, this is 1. 1 plus what equals to 5, so this will be 4. So now v5 is remaining. So minus 1 plus what equals to 5, so minus 1 plus 6 equals to 5. So now we have calculated all the values of u's and v's. Now we need to calculate the values at the non-basic cells, that means Cij minus of ui plus vj. So let us calculate. This is 6 minus of 0 plus 4, that means 6 minus 4 is plus 2. This is 9 minus 0 plus 6, that is 9 minus 6 is plus 3. Here it is 6 minus 1 plus 4, that is 6 minus 5 is plus 1. Here 7 minus 1 plus 6 is 6. 7 minus 6 is plus 1. 8 minus 1 plus 6, that means 8 minus 7 is plus 1. Here 8 minus of minus 1 plus 4, that means 8 minus 3 is plus 5. 9 minus of minus 1 plus 4, that means 9 minus 3, this is plus 6. Here 6 minus of minus 1 plus 5, that means 6 minus 4 is plus 2. And here it is 7 minus of minus 2 plus 4, that means 7 minus 2 is plus 5. Here also 7 minus of minus 2 plus 4, this will also be plus 5. 8 minus of minus 2 plus 5, that means 3. 8 minus 3 is plus 5. And 6 minus of minus 2 plus 6, that means 4. 6 minus 4 is plus 2. So now we have calculated the values at all the non-basic cells, and we can find that there is no cell which is showing negative value. That means if in any of the non-basic cell I allocate any value, it will only increase the overall transportation cost. That means our present solution is the optimal solution and it will not improve further. So now as it has been found out that this is our optimal allocation, we will find the value of z here, and z can be given as z minimum is equals to, this will be 35 plus this is 100 plus 60, 160 plus 150, this is 310 plus 35, 345 plus 25 is 360 plus 90, 370 plus 90 is 460 plus 50 is 510. So here our answer or the value of Z is 510 rupees. So this will be the minimum or the optimal value of minimum value of Z, and this is the optimal allocation for the given transportation problem. So if you like the lecture, please share the lecture. Have a nice day and Merry Christmas. Thank you.